So grade 10s, this is our first lesson for our term 3. Okay, so number patterns. This year we're only going to do our linear number patterns, which is patterns like 5, 8, 11, 14, 2, 4, 6, 8. Okay, do you see each time there's a constant difference? Okay, so this is where it's going to come in. Okay, so what is the difference between term 1 and term 2? So here we see 5, 8, 11, 14. So 5 we name as term 1 because it's our first term. 8 is term 2 because it's our second term. 11 term 3 and 14 term 4. So what is the difference between term 1 and term 2? So 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11 is 3. And it's very important that I add a positive 3 here, because later on you can sometimes see that it is, instead of 5, 8, 11, 14, that it's 14, 11, 8, 5. And then our difference would be negative 3. Okay. So when we move on, our general term is also Tn. So whenever they ask you for a general term, they ask for your Tn. When they ask for Tn, it's your general term. So now for the formula for a number pattern is Tn equals Dn plus C. Now that sounds very familiar because we know our linear line is y equals what? Ax plus C, or Ax plus Q, or whichever we decided. Okay, so now you see that this formula is the same as our linear line, because our linear number patterns, do you hear both has linear in the name? It's because they're all connected. So in the class we quickly touched on that, but we didn't go into much detail. So for this formula, and please make a note of it, you are going to use it a lot. So in this formula, our Tn we said is our general term. Our D here would be the common difference. Okay, so here we said the difference between term 2 and term 1, 3 and 2, and 4 and 3 is all 3. It's a common difference, it's a constant difference, and it's a difference of 3. Okay, so in this scenario, our difference would be 3. Okay, n is the position of the term in the sequence. Okay, so we said term 1, term 2, term 3, term 4. Okay, so in this one, if I'm talking about our third term, we will talk about this one. Okay, and C is a constant term. Now, for C, most of the times, you will have to work it out, meaning you'll substitute in your Tn, you'll substitute in your difference and which term, and you'll solve for C, and we'll get to that in a moment. Now, to get the common difference, we will always use this formula in a linear pattern. Okay, term 2 minus term 1. Now the question is, sometimes they're going to ask you what is the first term, but they'll give you term 2 and 3, or 3 and 4. And you just work it backwards. So it's always the second term minus the first term. So it can also be written as term 4 minus term 3. So always the second one minus the first one. Okay, when you do this, like for this instance, please remember your brackets. Like now we were lucky because term 5 is not a negative number. But as soon as there's a negative there, please remember to put it in here. So this is a general formula for your common difference. Okay, please remember that. Now, when we move on. Okay, hey, first example. Good. Let me just keep this one next to me. Okay. So example 1. Now, through this example, we're going to work through everything I just said. So don't worry too much, but please, for this one, pause for a second. Write it down, make notes of it. Okay, I want you to work with me through this. Okay, so pause, write down. Okay, now, our example, seedlings on a farm are planted around an underground watering system in the following pattern. Now, in the beginning, we're going to work with pictures. And many times, those of you who did the Olympiads, they give you pictures and ask you the question. But later on, we're going to work with words. Okay, they're going to tell me what they want. But for now, it's pictures, it's fun and easy. Okay, so our question is, how many seedlings will be in the fourth plantation? So this is plantation 1, plantation 2, and plantation 3. How many seedlings would be in plantation 4? Okay, we don't know that yet. We need to work that out. So my question is, how many seedlings is in the first and second and third plantation? Okay, so if we go count, it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, I write down 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I write down 12. And in my third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16. And now I have my number pattern. So when we worked on our first one, we had 5, 8, 11, 14. And our new pattern now of this plantations would be 8, 12, and 16. Now my question is, how many seedlings will be in the fourth plantation? My question to you first is, what's my difference between these ones? So I'm going to take my term 2, which is this one, minus my term 1. We said this is 12 minus 8. My difference is 4. So if the third plantation has 16 and the fourth plantation will have 16 plus 4, because we said our difference is 4, which means from this one to my second plantation, there's 4 more seedlings. From this plantation to this plantation, there's 4 more seedlings. So from this plantation to my fourth plantation, it means there must be 4 more. So 16 plus 4 would be 20 seedlings. So now I know in my fourth plantation, there'll be 20 seedlings. Good. So that is that for like the first part of it. Now, write a rule for the number of seedlings required for the nth plantation. As soon as you see nth, okay, I wrote here, when they ask you for nth, you think about Tn. So in the beginning, we talked about our general term is also Tn, okay? This is my nth term. Like, I don't know, like the nth plantation, my nth term. Okay, so what we know is that our pattern is 8, 12, 16. Perfect. We know our difference is 4. Good. So now I'm going to write my formula. And I'm going to substitute in everything we know. So I'm going to substitute my difference as 4. Perfect. But now my n and my tn and my c is unknown. Okay. And I need to solve c. But there's 4 unknowns, so that's not going to work. Okay. Now I'm going to substitute in. Now the tricky part comes in. I need you to bear with me. Okay. So we know a few other things. We know this is my term 1, my term 2, and my term 3. And I told you my term 1, term 2, term 3 is also my n. Okay, so if I go back to my first one, where here, the position of the term in the sequence. Okay, wait, let this just focus again. There we go. The position of my term in the sequence. So I know this is my first position, second position, third position, and fourth position, but they all have a value. The same here. So now I have my first position, my second position, and my third position, but they all have a value. That value is 8. My second position value is 12, and my third position value is 16. So now I know my first position, my n, okay, we said n is the position, so my first position value is 8. So that value I'm going to substitute in Tn. Okay. So because n, my first position is 8, I'm going to substitute it like this. So do you see Tn became 8? Because my n is 1. My 4 stays the same because that's my difference. And now I solve for c. So now, if they, let's say for instance, you didn't have your first term, but maybe your second term, your n would then change to 2. And your Tn would change to 12, because that's my second position, and the value of this position is 12. And I would still get to the exact same C. So here I wrote it again. 1, because we used the first term, okay? It's T1. 8, because the value of the first term is 8. The first position's value is 8. And then we solve for C like we do normal algebra. And because my question is, write a rule for the number of seedlings required for the nth plantation, we don't know what that plantation is, number what it is. So after I substituted in, I found C. C is equal to 4. I need to substitute it back into my formula. Okay, I need to substitute it back into this one. So then I say Tn equals 4n plus 4. My C is substituted back. So the reason to get this is, if they ask you, what would plantation 100 be? You know your position would be 100, and you can say how many seedlings. Okay, so this is where this question comes in handy. Now moving on. Okay, so now we know how to get our general term, our nth term. Okay, on from that. Okay, now how many seedlings will be in the 12th plantation? So this is what I just talked about. Okay, because we have our general rule, we can work from there. Okay, now in the 12th plantation, the term number 12, so n would be 12. So in our positions, we had that this is position 1, this is position 2, this is position 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we want how many seedlings would be here number 12? And yes, theoretically, you can go and add 4, add 4, add 4, add 4 the whole time until you get to number 12. Yes, that works for if they ask you the 12 for one, but imagine they ask you like plantation number 200. Like, please don't sit and add 4s for 200 times. Okay, this is where this comes in. So we substitute it into our formula. So we said 12th plantation, that would be our number 12 one. So n, our position, is 12, but we don't know the value of this 12th term. Okay, so that is our unknown, but we have only one unknown, so we can solve it. So we solve for term 12, 4 times 12 is 48, plus 4 equals 52. So we know in plantation number 12, there would be 52 seedlings. Okay. So how many seedlings will there be in the 12th plantation? There would be 52 seedlings. So again, do you see our Tn was the unknown value, the seedlings. So our 12th position value is 52. So n would always be our position, and Tn would be the value of that position. So again, when we look back at number, where are we? We are here. Okay. So when we look back at our first one, this is term 1, our value of position 1, our first plantation is 8. Plantation 2, our second position, n equals 2, and our Tn would be equal to 12. Now, T3, my third plantation, n would be equal to 3, but Tn would be equal to 16. Now, I'm repeating this many times because it is a common mistake, so please make a note of that n is always our position and Tn is the value of that position. Okay, then number D. Okay, so for this question, this is the last one, but it's a good one. Okay, let's do it. How many plantations will there be when there are more than 88 seedlings? So now the question is reversed. So now they're giving us 88 seedlings and they're asking us the plantations. So now they're giving us the value but asking us the position. Okay, we don't know what n is, but we do know what Tn is. So we know the value but not the position. Okay, side note, okay, when we say that the seedlings is Tn, and that a plantation is n. So I said this many times. This is just, again, like revising. Okay. Then we substitute what we have into our formula. So throughout this question, usually you will have one big question, like we had here, if I can find that paper. Okay. So this was our initial questions. Seedlings on a farm are planted around an underground watering system in the following pattern. And then you have sub-questions A, B, C, and D. So this whole time, you work on your formula that you got, your general term. Okay. So now we substitute what we have into our formula. Again, we found our C, we have our D, we continue. So we know our value is 88 seedlings, but we do not know our position. But that's very easy. When we substituted that in, we can now just solve n and get our position. Okay, so we take the 4 over, it becomes negative. 88 minus 4 equals 4n. How do we get this away? What's the opposite of times? It's divide. So now we divide by 4n on this side and divide by 4 on this side and divide by 4 on that side. And we get n as our 21st term. Okay. So when we have 88 seedlings, our position would be 21. Okay. Now, the question, very important, how many plantations will there be when there are more than 88 seedlings? So now we know plantation 21 would have 88 seedlings, but they're asking more than 88. So the plantation would have 88 seedlings, but the question was which plantation will have more than 88 seedlings. If 21 has 88 seedlings, then 22 must have more. Okay, so at position number 21, we have 88 seedlings, so position 22 must have more. It would be 88 plus 4 would be our position 22. Okay, so therefore my answer would be there will be more than 88 seedlings in the 22nd plantation. Now, you need to show me your calculations of getting to the 21st plantation has 88 seedlings and draw your conclusion by 3 little dots. Therefore, there will be more than 88 seedlings in the second plantation. Okay, I need to see your logic, how you got there. Now, here are 4 questions based on like your general term, but not this one, this one. Okay, so if by any chance you got your general term wrong, okay, many times in maths, and we talked about this in class, we mark on first mistake. So if you have this one wrong, but you use this formula in all your other ones, we would mark on your mistake. But again, if you make a second mistake along the line, unfortunately, you will not get that marks. Okay. But this is it for the number patterns. Please, please, please make sure you make all the notes when necessary. Write down your formula, what it means, and go through this again. Okay. Yes, and that is that for number patterns for our first lesson.